In this video, we're going to look at inverse functions. So inverse functions are functions. So f is a function, and its inverse should satisfy the following property. So if you have f compose f inverse of x, that should give you x. And f inverse compose f of x should give you x. So this is a property that inverse functions share. So basically, the idea is that you have your set of inputs, and then your function f takes it and maps it to a set of outputs, right? So basically, you have your inputs, they are being mapped to some output. Your inverse function takes these outputs and it maps it back to your input. So basically, all your output values, they get mapped back to their corresponding input values. And one very important fact that you need to know is that for a function to have an inverse, it must be 1-to-1. So this condition is very, very important, right? If it is 1-to-1, then it can be invertible. If it's not 1-to-1, so let's look at why a many-to-one function cannot be invertible. So suppose you have 2 points, right? And both of them are being mapped to the same output. The inverse function would map, see? So if you try to draw the inverse map, then this same point is being mapped to 2 different outputs, right? And we have discussed this reverse map will not pass the vertical line test. One input cannot be mapped to 2 distinct outputs. Every input must be mapped to a unique output. That is the definition of a function. So if it's many-to-one, then the inverse mapping does not qualify to be a function. All right, so now that we have established that, let's start with some questions. So we are given, find the expression for f inverse of x for each of the following functions, right? We have f of x is equal to 5x minus 8. So f of x is equal to 5x minus 8. Now, this is our output. X is our input. Let's say our output is y is equal to 5x minus 8. So let's imagine the map. We have our input x. Our function f takes this input and maps it onto our output set y, right? So our inverse function must take in y as its input and must map it back to x, right? So the idea is we want to make y the subject. We want to make y the independent variable. So to do so, I can add 8 on both sides. That is 5x. And then I can divide by 5. And now, what I want to do is I want to write f of x. So now that I've done this, x I want to write as f inverse of x, right? And y is just x, 8 over 5. So when you write your final answer, you want to switch your variables. So you want to write it as f inverse of x is equal to x plus 8 by 5. Now let's look at the function and its inverse. F of x is equal to 5x minus 8, right? So here's the idea. Suppose I put 1 here. If I put f of 1 is equal to 5 times 1 minus 8 is minus 3. If I put minus 3, if I put the output into my inverse function, f inverse of minus 3, I should get the input 1. So minus 3 plus 8 over 5 will definitely give me 1. So you can see how this works. A function takes an input, maps it to an output. Its inverse takes that output and maps it back to your corresponding input. So you can see how to get, so when you have a function, you now know how to get the inverse function. You now know how to figure out what the inverse function looks like. All right, so the only confusing step is that you replace y with your variable x, and then you replace your x, your new dependent variable, as f inverse of x, and that is it. All right, so part B. You have, and let me turn on my laptop as well so that I can check along as we go. All right, so we have f of x is equal to x squared plus 3. So y is equal to x squared plus 3, and y minus 3 is going to be x squared, and therefore x is going to be square root of y minus 3. F inverse of x is going to be square root of x minus 3. So that is going to be your inverse function for B. Now, one very important fact that we must discuss is that suppose you have a function f of x. It takes in an input, it maps it. So you have x is your input. Your function f takes it and maps it to an output, right? The set of all inputs, set of all allowed inputs, is your domain. The set of all allowed outputs is your range. So when the inverse function maps back, then the domain, so the domain of f inverse of x must be the range of f of x, right? So the range of f of x is the domain of f inverse of x. So the range is the input. So it becomes the domain of f inverse of x, and the domain of f of x becomes the range of f inverse of x. So that is another thing that you want to remember. All right, so let's continue. Part C gives us f of x is equal to x minus 5 squared plus 3. And you are given the restriction, right? You are given the domain restriction. So this is going to be the range of your inverse function. So y is equal to x minus 5 squared plus 3. Y minus 3 is x minus 5 squared. Square root of y minus 3 is x minus 5. And therefore, x is equal to y minus 3 plus 5. F inverse of x is equal to square root of x minus 3 plus 5. All right, so that is your inverse function. For D, I have y, f of x, is equal to 8 over x minus 3. So we'll not care about the domain and range. If the question asks us to care, then we will need to care. But for now, the question doesn't. We just need to find the expression, right? So let's just find the expression. So y is equal to 8 over x minus 3. So if I multiply by x minus 3 on both sides, I get y times x minus 3 is equal to 8. Yx minus 3y is equal to 8. Yx is equal to 8 plus 3y. And x is equal to 3y plus 8 divided by 8. Divided by y. So f inverse of x is going to be 3x plus 8 over x. So we are done with C and D. All right, and E. Sorry. So for E, we have f of x is equal to x plus 7 divided by x plus 2. So y is equal to x plus 7 divided by x plus 2. So we have xy plus 2y. If I multiply this here, I get x plus 7, and I want to isolate x. So I'll bring x here to my left-hand side, and I'll take y to my right-hand side. So xy minus x is 7 minus 2y. If I factor out x, I get y minus 1 is equal to 7 minus 2y. So x is equal to 7 minus 2y divided by y minus 1. And finally, I know that f inverse of x is 7 minus 2x divided by x minus 1. All right. So that is question 1 done. So now we need to talk about the domain and range. So that is important here. So we are given, you have a function f of x, and it maps to x squared plus 4x. And we can write it as x plus 2 whole squared minus 4. right? And we can visualize the graph. So if you complete the square, you get this expression. And when you visualize the graph, you get your vertex here. So it's concave up with vertex at -2 comma -4. So you have f of x has the domain x bigger than or equal to -2. So the range of f inverse of x is bigger than or equal to -2. The range is that f inverse of x has to be the domain. So f inverse of x is bigger than or equal to -2. And the domain of f inverse of x is going to be the range. So what is the range of f of x? Well, the range of f of x is that f of x is bigger than or equal to -4, right? -4 is the minimum point, and it's concave up, so every other value is going to be bigger than -4. So the domain is going to be x bigger than or equal to -4. So the range of f of x is the domain of f inverse of x. So that is something you want to remember. So this is the domain of f inverse of x, and this is the range of f inverse of x. So the domain of f of x becomes the range of f of x becomes the domain of f inverse of x. All right, and we need to find an expression. So if you're given a quadratic equation, to find the expression, it's easier if you complete the square. So you have y plus 4. So if you set f of x is y and you add 4 to both sides, you have y plus 4 is this expression. So x plus 2 is equal to square root of y plus 4. X is equal to square root of y plus 4 minus 2. F inverse of x, x plus 4 minus 2. All right. So that is going to be your expression. Moving on. Question 3. So you have f of x is equal to 5 divided by 2x plus 1. And your x is going to be your real number, and x is bigger than or equal to 2. So find an expression for f inverse of x. So y is equal to 5 over 2x plus 1. All right. So if I multiply by 2x plus 1 on both sides, I get 5. So 2xy plus y is equal to 5. And 2xy is 5 minus y. x is just going to be 5 minus y divided by 2y. So if I divide by 2y on both sides, I get this expression, and this gives me that f inverse of x is equal to 5 minus x over 2x. All right, so we have found an expression. So now we need to find the domain of f inverse of x. So the domain of f inverse of x is going to be the range of f of x. And f of x is 5 over 2x plus 1. Well, let's look at this as a translation of a graph that we know. And we know this is very similar to 1 over x. We know the graph of 1 over x. So I can write this as 5 over 2 divided by x minus x plus half, right? So this 2, when it comes down to the denominator, when you multiply by 2 in the numerator and the denominator, we get the given expression. So I just divided by 2 on the numerator and the denominator. So this tells me that my curves are very, very similar, except I have shifted it left by half units, and then I have stretched it by 5 over 2, but we don't really care about the stretch. So the graph looks something like this. All right, so now that we know what the graph looks like, let's consider the domain of f of x. And it's given, it's x greater than or equal to 2. So what is the value when x is equal to 2? Well, f of 2 is 5 over 2 times 2 is 4 plus 1. So that is 1. So when x is equal to 2, you have 1. And then it's everything beyond this point, right? All right, so now that it's everything beyond this point, we know that the range of f of x is that f of x is less than or equal to positive 1, right? Because it's this part. So f of x, the range of f of x for x bigger than or equal to 2 is that f of x is less than or equal to positive 1. Therefore, the domain of f inverse of x is that it is less than or equal to positive 1. So the range of f of x becomes the domain of f. So domain of f inverse of x is that x is less than or equal to 1, not f inverse of x. So that is going to be your domain. All right. So we're done with 3. Let's look at question 4. So question 4 is that you have f of x is equal to x plus 1 cubed minus 4 for x real numbers, and the domain of x is that x is bigger than or equal to 0. So A asks us to find an expression for the inverse function. All right. So if I add 4 on both sides, I get this expression. I take the cube root of both sides. I get this expression. And then finally, I can write x is equal to the cube root of y plus 4 minus 1. And basically, you can write x as f inverse of x is equal to the cube root of x plus 4 minus 1. All right. Or you can also write it as minus 1 plus cube root of x plus 4. Both of them work. All right, so that is the expression. Now find the domain of f inverse of x. Well, the domain is just the range of f of x. So let's look at the range of f of x. This, I know the graph of y is equal to x cubed. Y is equal to x cubed. The graph looks something like this. This tells me I shifted 1 unit to the left and 4 units down. So I shifted 1 unit to the left. So this point gets shifted 1 unit to the left, 4 units down. So it looks something like the green graph. That's very poor. So my function looks something like the green graph here. So now that I know what it looks like, and I am given x is bigger than or equal to 0, so let's evaluate this function at 0. Well, f of 0 is equal to 0 plus 1 cubed is 1 cubed, which is 1 minus 4, is negative 3. So at 0, it intersects at negative, so 0 comma negative 3 is a point. So let's just consider x bigger than or equal to 0, right? So that is going to be the range. So your range of f of x is that f of x is bigger than or equal to negative 3. So therefore, the domain of f inverse of x is that x is bigger than or equal to negative 3. And we are done. All right. Question 5. So we are given this expression, and let's look at it. So we have g of x is equal to 2x squared minus 8x plus 10. So 2, if I factor out the 2, I have x squared minus 4x plus 5, and I can complete the square. So x minus 2 squared plus 1, right? So if I draw the graph, so I can actually first let me multiply by x, by 2 inside. So 2x minus 2 squared plus 1. So it's concave up. I know where the vertex is. It's at 2 comma positive 1, right? So this is 2 comma positive 1 and concave up. So my graph looks something like this. And we are given x is bigger than or equal to positive 3. So our graph for this domain restriction, so if it's 3, then I have a point here. So if x is 3, then I have, I think, 3 comma 3. If you put 3 here, I get 3 squared is 9, 9 2 is 18, minus 24 is... So if you put 3 here, you get 3, I think. Let me check. So if you put 3 here, 9 2 is at 18, minus 8 1 8, 8 2 6, 8 3 is at 24, plus 10. So I made a mistake here. Oh, plus 2, because I multiply 2 here. Okay, so now that makes sense. So it should be 3 comma 4. And I'm considering this arm. So it says I'm considering this arm, right? So the question asks me, explain why g has an inverse. For x greater than or equal to 3, g of x is 1 to 1. The red portion is definitely 1 to 1, right? If you, without considering the blue part, if you draw a horizontal line, it's going to intersect only at one point. So that is why it is 1 to 1. So find the expression for g inverse of x. All right, so we're going to remember this. Right? We're going to remember this point. So g inverse of x, I'm going to use g of x is equal to 2x minus 2 squared plus 2 as reference. So y is 2x minus 2 squared plus 2. Y minus 2 is 2x minus 2 squared. And I have y minus 2 by 2 is x minus 2 squared. And I take the square root, I get y minus 2 by 2 square root is equal to x minus 2. And finally, I have x minus 2 by 2 plus 2 is equal to y minus 2 by 2 is equal to x, and therefore f inverse of x is equal to x minus 2 by 2 plus 2, but we need to give the domain, and the domain is going to be the range of f of x, which is that f of x is bigger than or equal to 4. So x is bigger than or equal to 4. So that is going to be my inverse function. All right. So yeah, the vertex is at 2 comma 2, my bad, because you have to multiply things inside to figure out. So you're shifting the graph 2 units to the right and then 2 units up. So your vertex is at 2 comma 2, and then it's 1 to 1 beyond it. All right, so we are done with question 5. Question 6. So we are given this expression. F of x is equal to 2x squared plus 12x minus 14. So I can factor out to 2. I have x squared plus 6x minus 7. And then I can complete the square inside. So x plus 3 squared minus 16. I think. I believe so. Because 3 squared is 9. And then 9 minus 16 should give me negative 7. But let me just check on my calculator very quickly. Yeah. All right, so now I multiply by 2 on the inside. I get x plus 3 squared minus 32. All right, so now I can draw the graph. It's concave up. My vertex is going to be at minus 3, 3 units to the left, and 32 units down. This is going to be minus 3 comma negative 32, and it's concave up. All right. So the least value of k for which f is 1 to 1 is going to be negative 3, right? Negative 3 is the smallest value beyond which, if x is greater than or equal to k, then x has to be negative 3. So we're going to consider this arm. So the least value of k is that it's negative 3 for the function to be 1 to 1. All right. So find the expression for f inverse of x. So we're going to use this form. We're going to set it to y, right? F of x is equal to y. So y plus 32 divided by 2 is going to give me x plus 3 squared. And if you simplify, you get minus 3 plus square root of y plus 32 by 2. That is going to be your x. And you can conclude that your f inverse of x is just minus 3 plus square root of x plus 32 by 2. So I did it quickly, but I think you're used to the algebra by now. All right. So moving on to question 7. Find the range of f. So we are given a function. Find the range of f. All right. So f of x is x squared minus 6x. Can be written as x minus 3 squared minus 9, right? And we can plot the graph. So our vertex is going to be at 3 units to the right and 9 units down. So our vertex is going to be at 3 comma minus 9. So your range of f is that f of x is always bigger than or equal to negative 9, right? Because it's concave up. So it's always bigger than or equal to negative 9. State with the reason whether f has an inverse. No, f does not. So for this domain, right, we are considering x is a real number. So for this domain, no, f does not have an inverse because it is not 1 to 1 for x element real number. So for this domain restriction, f is not 1 to 1, therefore it does not have an inverse. All right. Question 8. So we are given an expression for f of x. So f of x is equal to 9 minus x minus 3 squared for x real numbers. And we are given a restriction for our domain. State the smallest value of k for which f has an inverse. So let's draw the graph. So this is minus x minus 3 squared plus 9, right? So this minus sign tells us that it's concave down. So minus x squared looks something like this. Concave down. So we're shifting it right 3 units and up 9 units. So our final graph looks something like the one I've drawn in purple. So if it's 0, then it passes through 0, 0, I believe. So something like this. All right. So this is what the graph looks like. So it says find the expression. So state the smallest value of k for which f has an inverse. So now the maximum value that x can take is 7, right? So if x is equal to 7, let's just plug it in. F of 7 is equal to minus 7 minus 3 is 4 squared plus 9. So that is minus 16 plus 9 is minus 7. So if x is 7, it's... So we need to find the smallest value of k for which f has an inverse. So let's just trace back. If I trace back, up until the vertex point, my function is 1 to 1. So your smallest value of k is going to be the k where your vertex occurs, and that is when x is equal to 3. So therefore, k is equal to 3. If you take any value that is smaller than 3, then it's no longer 1 to 1. All right. So for 8 is 3. And then it says for this value of k, so we know our k value, it is 3. We need to find an expression for f inverse of x. All right. So f of x is equal to 9 minus x minus 3 squared. So let's just say this is y. And now I can write it 9 minus y can be written as x minus 3 squared, right? If I add x minus 3 squared on both sides and I subtract y on both sides, I get this expression. And then I get this expression. And finally, I get x is equal to 3 plus square root of 9 minus y. And f inverse of x is equal to 3 plus square root of 9 minus x. All right, so that is going to be your expression. And then it says state the domain and range of f inverse of x. The range is going to be the domain of f of x. So range of f inverse of x is equal to domain of f of x, and therefore f inverse of x has to be between 3 and 7. And now, within this domain, what is our range? Our range for f of x, range of f of x for this domain is that f of x is smaller than or equal to 9, because your vertex is at 3, 9, so your 9 is max, and it's bigger than or equal to -7. Your red part does not go lower than -7. So therefore, your domain for f of inverse of x is that x has to be bigger than or equal to -7 and less than or equal to 9. So continuing with more questions. Okay, my microphone is on. So question 9 says, we are given the graph of y is equal to f inverse of x, where f inverse of x is given by this expression, and we are given the domain, which is going to be the range for my f of x. And yeah, we are given the domain. All right. So find an expression for f of x. So now you want to know that f inverse of x, if you take the inverse of this graph, so f inverse is just going to be f of x, right? So you have f inverse of x, and you make the inverse function of that inverse function, you get your original f of x. All right, so we now have f inverse of x is equal to 5x minus 1 divided by x, and we want to follow the same procedure to get the inverse function of f inverse of x, which is going to be f of x. So we have 5x minus 1, xy, if I multiply by x on both sides, I get this expression, 5y minus 5x is -1, right? Or if you don't want to work with -1, you can actually do 1 is equal to 5x minus xy, whichever way you prefer. And I can factor out the x. And if you factor out the x, you will see that you get this expression. And finally, you can get f of x is equal to 1 over 5 minus x. All right, so that is going to be your expression. And let me just turn on my laptop as well on the side so I can keep checking these answers as I go, because I'm also doing these questions on the fly. All right, so that is the expression for f of x. Now state the domain of f. All right, so now let's look at the graph of this function. So the range of f inverse of x seems to be so let's think about it, right? Well, it goes up, down until -infinity. And then it goes up, it increases, and now we want to figure out whether does this graph become constant or is it still increasing, right? So now let's look at this equation. Y is equal to 5x minus 1 divided by 5. And from the numerator, let me factor out if x. So I have 5 minus 1 over x divided by x, right? I just factored out the x. And now because x, I am looking at non-zero values of x, I can cancel these out. So I have y is equal to 5 minus 1 over x. Now if I take really, really big values of x, as x tends to infinity, if I take really, really big values of x, this is going to become 0, right? 1 divided by a very big value of x is going to get closer and closer to 0. So y gets closer and closer to 5. So this we will discuss more when we discuss about asymptotes, but we have a horizontal asymptote when y is equal to 5. So y approaches 5 as x approaches positive infinity. All right. So that means that our range of this function starts from -infinity and it goes up until 5. So it's never going to be exactly equal to 5. It's going to approach 5. And now that we know that, the domain of this function is going to be x less than 5, right? Of course, it's going to be bigger than -infinity, but it's going to be less than 5. But we also have to take into consideration this domain. So x less than 5 is for the whole graph, right? We are not restricting it to this domain. We have considered all real numbers for its domain. So now let's take into consideration the domain restriction. So now f inverse, it cannot be 0, but f inverse of 3 is 5 3s of 15 minus 1 by 3. So 14 by 3. And bigger than 0, right? So if you can't plug in 0. So you can't plug in 0 into your inverse function, right? So your graph is actually restricted. It goes here, and then it goes up until x is equal to 3. 3, right? So your actual range for this function is going to be x less than or equal to, and whatever 3 is. So that is 14 by 3. So less than or equal to 5 was for the whole graph. This is when you take into consideration this domain restriction. So now you have x is less than or equal to 14 by 3. 14 by 3 is like 4/2/3. All right. So that is the range for f inverse of x. So that is going to be your domain. So the domain of f is going to be this. All right. So we are done with question 9. Question 10, we have f of x is 3x plus a. So just to clarify, when we took into consideration the whole input values, right, from x bigger than 0 to x positive infinity, we figured out that, hey, the graph sort of flattens out as y tends to 5. But then when we consider this domain restriction, we see that my range for this graph, which is the f inverse graph, is going to be less than or equal to 14 by 3, which is 4/2 by 3, right? So this restriction, this range for my function is going to be the domain for my inverse function. So the inverse of the inverse function is just my f. So that is why this is the domain of f. All right. So question 10, we are given f of x is 3x plus a. We have a function g. The g of f of minus 1 is equal to 2, and g inverse of 7. Oh, we are given g, sorry. I thought we were not given g. Okay. G of x is equal to b minus 5x. All right. So gf of minus 1. So let's just find gf of x. So we take the function g, and where we have x, we substitute in f of x. And let's simplify. So b minus 5 3s are 15x plus 5a. And finally, we have minus 15x plus b minus 5a. So that is going to be my expression. And we know that gf of minus 1 is 2. All right, so if I substitute minus 1 here, I get 15 plus b minus 5a. That is 2. And therefore, b minus 5a, if we subtract 15 on both sides, I get negative 13. All right, and we have g. So y is equal to b minus 5x, and we want to find g inverse. So b minus y is going to be 5x, right? So if I take 5x to the left-hand side and y to the right-hand side, I get this expression. And then x is going to be b minus y over 5. And therefore, g inverse of x is going to be b minus x over 5. And we need to calculate g inverse of 7. So g inverse of 7 is going to be b minus 7 by 5. And that is, we are given the value of g inverse of 7 to be 1. So b minus 7 is 5 times 1, which is 5, if I multiply by 5 on both sides. And b is just 12, if I add 7 on both sides. And when you know that b is 12, you can just substitute it here. So, right, 12 minus 5a is minus 13. You subtract 12 on both sides, you get minus 25. Cancel out the negatives, and you get 5. So, a5 and b12 are going to be your answers. All right. So, question 10, we are done. Question 11. So, f of x is 3x minus 1. G of x is this. So, find expressions for, okay. So you have f of x is equal to 3x minus 1 for x is equal to real numbers, right? Y is equal to 3x minus 1. Y plus 1 is equal to 3x. And then finally, x is equal to y plus 1 by 3. So f inverse of x, right, is going to be x plus 1 by 3. Now let's go for g inverse of x. g of x is equal to 3, 2x minus 4. So this is y is going to be 3, 2x minus 4. And then I multiply by 2x minus 4 on both sides. I get 3 because it's going to cancel out with the denominator, right? If I multiply on the numerator. So I have 2xy minus 4y is equal to 3. If I add 4y on both sides, I get 3 plus 4y. And finally, I can isolate my x to be 3 plus 4y over 2y. And therefore, g inverse of x is going to be 3 plus 4x over 2x. All right, so now I know the expressions, and then show that the equality of the two inverse functions has two real roots. All right, so we can just show it as follows. X plus 1 by 3, that is f inverse of x, and I want to make it equal to g inverse of x. So if I cross multiply, x plus 1 times 2x should equal to 3 plus 4x times 3, right? So I just multiply by the denominators on both sides. All right. So if you simplify, you get 2x squared plus 2x. And on the right-hand side, you get 9 plus 12x. Now you can write this as 2x squared minus 10x minus 9 is equal to 0. So I subtracted 12x on both sides, and I subtracted 9. Now let's look at b squared minus 4ac. That is my discriminant, right? So b is negative 10. If you square it, you get 100 minus 4. A is 2. C is negative 9. So 100 minus 4 2s are 8. 9 8 says negative 9 times 8 is negative 72. So you have plus 72, which is 172, which is bigger than 0, right? So therefore, this, if you have a positive discriminant bigger than 0, then you have two real distinct roots. So you just check the discriminant. All right, so we are done with question 11. And let me just put my iPad on charge very quickly so that it doesn't die on me. All right. Okay. So question 12. We are given f of x. So f is a function that maps x to 2x minus 1 cubed minus 3. And then your domain for x isn't real number is this. All right. So we are asked to find an expression for f inverse of x. All right. So y is just going to be 2x minus 1 cubed minus 3. Add 3 on both sides. You get this expression. You take the cube root of both sides, and you get 2x minus 1. And then you add 1 on both sides. And you can divide by 2 later, and you get x as follows. Another way to write this, which I prefer, is like this. Equal to x. And therefore, f inverse of x is going to be x plus 3, 1 over 3 plus 1 by 2. So that is your f inverse function. So if you check your... So for part B, for 12, we need to find the domain of f inverse of x. And to do so, we need to look at the range of f of x. So f of x, let me write it out again, is 2x minus 1 cubed minus 3. And we are given the domain restriction as this. So let's try to visualize the graph. I know we haven't done graph transformations yet, but let me give you a gist. So we are going to start from the inside out, right? So basically, we're going to start with minus 1. And basically, having 2x minus 1 tells me that I need to translate the graph 1 unit to the right. So what is my base graph? I know the graph of x cubed. And this is just a modified version of x cubed. Instead of x, I have 2x minus 1. So my graph of x cubed looks something like this. My graph of... So 2x minus 1 tells me first, if I start from the inside, I need to translate 1 unit to the right. So translating 1 unit to the right. And now I need to do 2x. So 2x basically means I am going to have, so 2x implies I need to have, or basically 1 over 2 times my, so basically if you have nx, then it's going to be 1 over n times my x coordinates with an invariant y-axis. So the y-axis values do not change, but my x-axis values have to be halved. So now the graph is going to look something like this. It's going to look like it's been stretched. That is a bit poor, actually. So now I need to make it look like my graph has been stretched, right? So something like the blue line. And then I need to translate it 3 units down. All right. So then finally I get my graph. Something like the orange line, the red line, sorry. So my graph is going to look like the red line. So something like maybe like this. This is very poorly illustrated, I know, because the shape should be something like this. All right. So let's just say something like this. I'm very bad at drawing this. All right. So now let's just check the input values. When x is equal to 1, 2 times 1 is going to be, what is it going to be? 2 times 1 is going to be 2, minus 1 is 1, 1 cubed is 1, 1 minus 3 is, so if my x is 1, then my y is minus 2, right? And if my x is 3, if I put 3 here, my output value, 2 3s is 6, minus 1 is 5, 5 cubed is 1, 2, 5 minus 3 is 3, comma 1, 2, 2. So my range is going to be here, and that is going to be my domain for f inverse of x. So domain of f inverse of x is going to be the range of f of x, and therefore x is bigger than or equal to -2 and less than or equal to 1. All right. Sorry, less than or equal to 1, 2, 2. Because it goes up until 1, 2, 2. All right. All right, so we are done with question 12. I hope that was a clear explanation. So we move to question 13. So we have f of x, it maps to x squared minus 10x for x bigger than or equal to 5. So x is going to be a real number all the time for our course. So express f of x in the form. So basically this question asks us to complete the square. So that is going to be x minus 5 squared plus 25. Sorry, minus 25. And if you basically you take half of 10, you put it inside the square, so you copy the sign, so x minus 5. So this is ideas from the topic completing the square, which we have already done. So x squared minus 10x plus 25 minus 25 will give you this expression. All right. So we are done with A, pretty much. And for B, it says find an expression for f inverse of x and state the domain of. So first of all, let's just visualize the graph of this function. So we want to take the graph of x squared. We want to translate it 5 units to the right and 25 units down. So maybe 5 units, I'll express it here, and then 25 units down, and it's going to be concave up. So something like this, right? So this is going to be 5 comma negative 25. All right. And we are given this domain restriction. So we are only want to consider this part, the red arm of the branch. All right. Sorry. We only want to consider the red arm of the branch. So now we want to find an expression for the inverse function. So to do so, we'll just use our usual method. So y plus 25 is x minus 5 squared. And now y plus 25, if I take the square root, is going to be x minus 5. And then finally, x is going to be y plus 25 plus 5. And therefore, f inverse of x is going to be x plus 25 plus 5. And now let's check with the value, right? If I put in, say, 6 into f of x, so f of 6 is 1 minus, so negative 24, right? So if I put negative 24 here, I should get 6. So negative 24 plus 25 is 1, square root of 1 is 1, plus 5 is 6. Yeah, so it works for this arm of the branch. But what if, the question is, what if we were restricting it to the other arm of the branch? Then this expression will not give the inverse function. So if we had restricted the left arm, so if our domain had been x less than or equal to 5, it's x greater than or equal to 5, then how do we get the inverse function? Well, the idea is that you have this expression, right? Y plus 25 is equal to x minus 5 squared. Well, you want to take the negative square root. So you take the square root, you want to take the negative value of it. And therefore, x is going to be 5 minus y plus 25. And now you can check. If you put in f4, f of 4 should also give you negative 24. And if you put negative 24 here, you're going to get 4, right? So that is if we have to restrict the other arm of the branch. Then we take the negative square root. Not, you take the square root and then you consider the negative value of it. Not, there's like, you can't take the square root of a negative number. All right. So it says find the domain. Yeah, so it's going to be the range. So the range of f of x is that f of x is bigger than or equal to negative 25. So therefore, the domain of f inverse of x is that x is greater than or equal to negative 25. All right, so we are done with question 13. So, sorry, if that wasn't clear, this is the answer. And this is the answer. All right. Question 14. F of x is 1 over x minus 1. F of x is 1 over x minus 1. X cannot be 1. Right? Yeah. For all real numbers, x not equal to 1. So we want to find an expression for f inverse of x. That is routine, right? If you multiply by x minus 1 on both sides, you get yx minus y is equal to 1. Yx is equal to 1 plus y. X finally is equal to 1 plus y by y. And therefore, f inverse of x is 1 plus x by x. So that is the expression. Show that if f of x is equal to f inverse of x, so this is f inverse of x, this should be equal to f of x. F of x is just 1 over x minus 1. So 1 plus x, I can write it as x plus 1. Now, cross multiply. So I multiply by 1 on both on both sides, and I multiply by x minus 1 on both sides. Remember, this is x plus 1, x minus 1. It's just going to be x squared minus 1. And if you subtract x on both sides, you get this expression. All right. So find the values of x for which this equation is satisfied. So basically, they want us to solve this equation. So we'll use the quadratic formula. X is equal to b squared. B is negative 1. So a is 1, b is negative 1, c is negative 1, right? So b squared minus 1 squared is 1, plus or minus b squared, plus or minus square root, sorry, let me think. No, that the quadratic formula is minus b is 1, plus or minus the square root of b squared, which is 1, minus 4 times a is 1, c is negative 1, right? So if you think about it, I have 1 minus of minus 4. So that's going to give me 1 plus 4 over 2a times 1 is 2. 1 plus or minus square root 5 by 2. So therefore, x is going to be half 1 plus square root 5. And x is going to be half 1 minus square root 5. Right? So those are going to be your two solutions. Insert form. Or you can just leave it as this, actually. All right. So we're done with question 14. That was quite straightforward. Okay, question 15. Determine which of the following functions are self-inverse functions. So for a function to be self-inverse, it means that f of x is equal to f inverse of x. In the next topic, we will discuss that if this is the case, then the graph of the function is symmetrical about the line y is equal to x. All right. So A is I have f of x is equal to 1 over 3 minus x, x not equal to 3 in the domain. So y is equal to 1 over 3 minus x. If I multiply by 3 minus x on both sides, I get this expression, 3y minus xy is equal to 1, minus xy is equal to 1 minus 3y. And finally, x is equal to 1 minus 3y divided by minus y. X is equal to 3y minus 1 over y. So f inverse of x is equal to 3x minus 1 over x. This does not equal to 1 over 3 minus x. Therefore, not self-inverse. All right. So A is not self-inverse. This is no. So let's look at B. We have f of x is equal to 2x plus 1 divided by x minus 2 for x not equal to 2. Y is equal to 2x plus 1, x minus 2. And if I multiply by x minus 2 on both sides, I get xy minus 2y is 2x plus 1. Right? All right. So now I have xy minus 2x is equal to 1 plus 2y. Because I want to isolate x, right? So I bring my x terms to the left-hand side. I take this term to the right-hand side. So I can take out and factor out the x. I get this expression. And finally, x is going to be 1 plus 2y divided by y minus 2. So therefore, f inverse of x is going to be 1 plus 2x, x minus 2. And this is exactly equal to 2x plus 1 divided by x minus 2, right? Because 1 plus 2x is 2x plus 1. So therefore, this is a self-inverse. All right. So B is self-inverse. And finally, let's look at C. C just says f of x is equal to 3x plus 5 over 4x minus 3 for x not equal to 3 over 4. All right. So y is equal to 3x plus 5 over 4x minus 3. 4xy minus 3y is equal to 3x plus 5. Right? So 4xy minus 3x is going to give you 5 plus 3y. I factor out the x. I have 4y minus 3 is 5 plus 3y. And then x is going to be 5 plus 3y over 4y minus 3. And I can rewrite this as 3y plus 5, 4y minus 3. And therefore, f inverse of x is equal to 3x plus 5, 4x minus 3. And that is the same thing as I have here. So C is also a self-inverse. Yes. Yes. All right. Finally, we are at question 16. F of x is equal to 3x minus 5. G of x is equal to 4 minus 2x. So we want to find an inverse of f compose g inverse. So let's find f compose g first. So 3, and instead of, I take f of x, and instead of x, I substitute in g of x, right? Minus 5. All right. That is 12 minus 6x minus 5. That is 7 minus 6x. All right. And now I want to find the inverse of this. So y minus 7 is equal to minus 6x. 7 minus y is going to be 6x. So I multiply by negative 1 on both sides. X is 7 minus y over 6. And therefore, f inverse of x, sorry, not f inverse of x. This is fg inverse of x is going to be 7 minus x over 6. Now I need to find G inverse composed F inverse of x. Alright, so first of all, let's find F inverse of x. F of x is 3x plus 5. It's 3x minus 5, sorry. So y plus 5 divided by 3 is going to give me x. So therefore, F inverse of x is just x plus 5 divided by 3. G of x, so we'll invert g of x, is 4 minus 2x. So 4 minus y is equal to 2x if you simplify. And x is going to be 4 minus y divided by 2. So g inverse of x is 4 minus x divided by 2. So now we need to find G inverse composed F inverse of x. So let me just take the expression of G inverse and I substitute x plus 5 over 3 inside. So now I need to simplify. 4, I can write it as 12 over 3, right? With a common denominator of 3 minus x plus 5 divided by 3 over 2. And now if you do a bit of algebra, you'll see that this expression actually equals to this. And I have 12 minus x minus 5, so 7 minus x over 6. And you will notice that fg inverse of x is equal to g inverse f inverse of x. So that is the observation, right? And this is true if the inverses are defined, the domain and range are compatible. So if these conditions are satisfied, then yes, this result will be true. And if you think about it, let's consider what this means. You have an input x, right? The function g maps it to g of x, and the function f maps it to f, and the function f maps it to something, right? So let's say g of x is equal to u, so the function f maps to f of u, right? So the function fg of x maps from the first to the final set, right? Directly. It skips the mapping of g of x. That is something we have discussed. So inverting this, so fg inverse of x, right? Which is the expression that we have here. That is the reverse map. That is the map in pink. And to get there, what do we need to do? Well, first we need to do the inverse map from f, right? We need to apply f inverse first, and then we need to apply g inverse. So that is the order here. We need to apply f inverse first, and then we need to apply g inverse next. So that is what the final expression is just telling us. All right. So basically f inverse first, and then you apply g inverse after you have applied f inverse. That is what part 16 is telling us. And that is it for this topic.